We're going to cover this big topic of tautomerization. Let's see if I can spell it correctly. Is a huge topic. We're going to cover one specific aspect of it, specifically tautomerization of ketones. So let's draw a nice simple ketone, acetone. As it turns out, when you have a bottle of acetone, it is in equilibrium with another form. And that other form looks like this. Acetone, the way we typically draw it, is the keto form. But there's just a little bit of it, about 0.1% or so, which exists as the enol form. So let's say about 99.9%. This is about 0.1%. Now, if you took an NMR of acetone, what you would see is a molecule that just has simple methyl groups, okay, CH3s. You wouldn't see this alkene in there. So there's so little of it, of this enol form, you can't even see it by NMR. These are called tautomers. And they are structural isomers. Tautomers have the same molecular formula. Both of these are, what are they? They're C3H6O, but we have a different bonding arrangement here. Tautomers specifically are structural isomers that involve the movement, and it's a 1,3 relative movement of a hydrogen and an alkene. So we have over here on acetone, we have that hydrogen. What we've done is we've moved this hydrogen over to the oxygen, and likewise, so in addition to the hydrogen, we've moved the alkene over to between the carbon-carbon atoms. Note that this is, whenever we move alkenes, I think it's very easy to try to make a connection to a resonance. This is not resonance. Now, in resonance, we oftentimes do move pi bonds. However, in this case, we're not just moving the electrons in a pi bond, we're also moving the hydrogen. And the rule in resonance is you can't move nuclei in resonance. You're only moving electrons. So since we're moving this hydrogen atom, technically we are not doing resonance. In fact, it's not even technically, this is not resonance. So anytime you see pi bonds moving around, it's not always resonance. Make sure that nuclei are not moving as well. But tautomerization is an important process. We're going to see it come up quite a bit later in this second semester organic chemistry class.